12 years, came back. Now I'm a faculty at IIT Madras. There's a lot of confusion about what is chemical engineering, what is chemistry, is chemical engineering or chemistry, how much of physics and math is there, how much of computation is there, and so on. So all of these are standard questions that students usually have. What I'm going to give you is an idea of what chemical engineering it is. And actually, I can tell you, I myself, I guess you guys are all lucky that you have sessions like these, where you can listen to various faculty from different fields and understand what people do, how things are, and then really make informed choices. In our times, again, pretty similar to what you guys might be going through. You got a rank, that rank kind of dictated where you wanted to go and what you wanted to do. So I got chemical engineering. I didn't know what it was. Like, I wouldn't have known what electronics and communication was, or aeronautical was, or computer science was, and so on. So I just went in, and then initial thought was that it's going to be maybe a lot of chemistry, again, not having much difference. But my boy, what difference it has been for me. It's just an eye-opener for me all through my life. And the most important thing that I want to even say before starting this is that remember one thing, which is very, very important, right? The degree that you have is supposed to tell other people around that what you are likely to know, right? So if I'm a chemical engineer, they will assume that I know certain things about chemical engineering. But chemical engineering itself is so vast that it's impossible for someone to know all of chemical engineering. But more importantly, what I want you guys to really understand is that the degree that you have does not define what you do not know. So in other words, because a chemical engineer, you cannot assume that person does not know any electrical or mechanical stuff. Or if you're a computer science graduate, they don't know any chemistry and so on. I think the world is changing dramatically. Everything is interdisciplinary, and the basic degree takes you only so far. And the basic degree essentially in an IIT, and this was true at IIT Madras, this was true at IIT Bombay where I've taught, and I'm sure it's true at any IIT, only tells you how to learn things. And nowadays, with so much information out there in the open source, it's easy to pick up all kinds of information that you want. However, you have to continuously learn. And basically, your field or the course you have taken does not stop you from doing anything. Just so that you know, most of my career, I worked in AI and data science because I was very interested in this right at the beginning. As soon as I came to my fourth year of chemical engineering, I did a project on developing an expert system for doing some decisions in chemical engineering. But I got fascinated by that. I did my PhD. I worked on neural networks and so on when they were very popular in the late 90s. And then for a while, they were not popular. Now, neural nets everywhere. And I've been in this field all through my life. So again, it's not to say everyone should do AI, data science, and so on. But essentially, whatever you are doing does not really, at the engineering undergraduate level, does not define what you will be doing later. Okay, so let me just kind of talk about chemical engineering. I've had a fantastic career doing chemical engineering. And I'm sure this will be true of any engineering. Any faculty who comes and gives a talk here will pretty much say the same thing, that it doesn't matter. Right? Because what is your passion? Every field allows you to take your passion and move forward with it. Now, there are different ways to think about chemical engineering. Again, I'm very biased because I've got a living out of chemical engineering. I've enjoyed every moment of my, starting from my undergraduate all the way in research, in teaching, in consultancy, in everything. I've enjoyed myself. So I'll be very biased and I will say I have really nothing to complain about. But it's for each of you to figure out what your interest is. And this I'm saying with someone who didn't even know what chemical engineering was and started enjoying this. And essentially, when I was making this choice, I had a lot of enthusiasm and interest for math. I got through Olympiad. I did multiple things, and I was actually debating about doing whether a BSc in mathematics or chemical engineering. That's the only thing that I was thinking about. In engineering, I had no idea. But then I started doing chemical engineering, and now I do a lot of math in chemical engineering, which is very fascinating, fantastic for me. Anyway, coming back to chemical engineering, essentially, chemical engineering has aspects that go all the way from quantum principles and things that happen at the quantum scale, all the way up to ecological systems. So we look at all of this, and I'll show you the next slide where you'll see how all of this is connected. And it's like an elephant and five blind men. If you say, what is chemical engineering? Someone who is working on climate adaptation might say, these are aspects of chemical engineering that are very interesting to me. Or for someone who works in this area of process systems engineering, that's what I do. We'll say chemical engineering is a lot of math, very nice control algorithms, machine learning, AI, and so on. And if you talk to a polymer scientist who is working on chemical engineering, they will give you a different perspective of chemical engineering. And I'm assuming this is largely true of all disciplines. So essentially, you peg yourself at some scale, both time and space. For example, if you're talking about process systems engineering, typically till some time back, it was basically in the time scales of seconds to hours. And we are talking about actual process equipment and so on. And how do you control this equipment? How do you figure out if there are things that are going right or wrong? And so on. Okay, so it spans this whole time and space spectrum. And there are major developments over decades that change the way that chemical engineers work. Now, chemical engineers will have to learn a lot of math. Chemical engineering, you cannot do basic understanding of chemical engineering if you cannot understand partial differential equations, if you cannot work with partial differential equations. You cannot be a great chemical engineer if you don't have a very systems view of taking a system, decomposing it, bringing it down, and understanding it, and so on. So all of this, you have to get better and better at these as this field grows, and the field grows into multiple areas, right? So did you know that in semiconductor industry, one of the most important things that they do, which is called chemical mechanical planarization, it's called CMP, it's all done by chemical engineers, right? So in every one of these, so if you take anything that you think is very exciting, cool, and so on, there will be technology from different disciplines that come into this picture. This chemical mechanical planarization is essentially when you have these chips, how do you make it very, very smooth surface, right? How do you polish that surface? And IBM labs and Intel labs have huge groups that work in CMP, and all of those are manned by chemical engineers. So what I'm trying to say is, depending on what area you focus on, there are sub areas in different fields of chemical engineering. Essentially has a part to play. And of course, many of these are related to chemical reactions, related to mass balance, mass transfer, momentum transfer, energy transfer, and so on. And the key courses that you learn in chemical engineering are transport phenomena, which is highly mathematical. This is where lots of PDEs, you have to understand how PDEs are solved, how do you use these PDEs, and so on. Thermodynamics, you already would have some idea of what it is all about. Reaction engineering, essentially, when you balance mass, when you have reactions also happening, you add that to it, that is reaction engineering. And how does all of this come together towards designing systems that are robust, that are resilient, that work, that make products that all of us use, right? From your slippers that you wear, the plastics, to the flights that we fly in, those are all material aspects, and they have to be made somehow. So how do you make them? Essentially, in a chemistry lab, at a molecular level, at a very small beaker level, you will understand how to make these chemicals. And chemical engineering will teach you how to take these experiments in the lab and things that chemists have understood in the lab, scale that to a big reactor to produce lots of this, right? So when you go from this small scale to large scale, that's where chemical engineers come. And that's where you have to design these processes and so on. And then chemical engineer and material scientists and material engineers will characterize these, make sure you make the right material for the right application. So, for example, in aircrafts and so on, you have to have lightweight materials which have enormous strength. So how do you make that? So you have to look at what material will have those characteristics, and what are the starting reactants from which you can make these materials and so on. All of those are things that chemical engineers do work on. Now, again, I think most faculty, because we are very passionate about what we do, because we will not be doing this otherwise. I have opportunities to go anywhere I want. I still continue to do what I do in chemical engineering, simply because I love this field, right? And so everyone will say this is the most important field right now. But I tell you one thing, though, the most important questions that face mankind have to be solved by all engineers working together. And chemical engineers have a very, very critical part to play in the current social need. Let me give you a very, very simple example. We last few days back, you would have heard this India's GDP is growing. It's the fastest growing GDP in the world. Now we are the fifth largest, and we are likely to be the third largest in a few years, and maybe the second largest, and maybe even the largest. There are predictions that talk about all of this. There's never been growth in GDP without growth in energy consumption. So very rarely or almost never will you have GDP grow and all the total energy consumption coming down. So that's simply not possible, because for GDP to grow, you have to make things, you have to work with work with things. That basically means you have to expend energy. Okay, so energy consumption, energy utilization is going to grow. So if you are talking about GDP growth here in India, then essentially the energy consumption has to go. As more and more people move into the middle class, then you have to have more and more energy that is consumed. Now, you know that when you produce energy, you also produce greenhouse gases, and that is going to have a severe impact on climate, and it's already had a severe impact on climate. So climate change and energy are related, and this is a problem that the mankind has to solve to be living here sustainably. And what is at the core of this? The core of this is energy systems, where transformations take place, whether you're taking the energy from materials and then producing energy, all of these become some form of reactions. And every energy system that you can think of, right, you will have chemical engineering play a role. So, for example, if you think of fuel cells, that is right in the field of chemical engineering with electrochemistry, with mass balance, mass transfer, making sure these things work well. So you have chemical engineering. Even take something like if you take solar cells, for example, all chemical engineering, because you have to get the correct materials for the solar cells, and that you have to produce. Think about turbines, again, materials. So chemical engineering and, of course, metallurgy, material science are going to play a very, very important role in all problems related to energy, and problems related to climate change and pollution abatement and so on. So the most important problems that are facing the mankind, chemical engineers will have a very important role to play in solving these problems. Of course, every bit of research is going to become interdisciplinary. It's not going to be one field that you'll have to work with. A chemical engineer has to learn lots with other engineers and work together. So it's going to be interdisciplinary work that's going to drive the work as we go forward. And of course, the biggest buzzword now is AI, and I don't know how many of you know, chemical engineers have been working on AI systems for many, many years. In fact, there were very large AI conferences and applications of AI in chemical engineering in 1970s and so on. So that gives you different ways in which you can think about chemical engineering. So I told you this, one very quick slide on this. So the scale is from quantum all the way up to a large geographical scale. And essentially, both are connected through multiple operations that we do to make products, to understand how the systems work. So here you see a spectrum from quantum mechanics to active species on catalyst surface. And then a little bigger scale pores in a catalyst, bigger scale is a fluidized bed. Then you make it bigger, a plant and many plants, and then things being produced, city, effluent, climate, and so on. So you can see that this whole gamut of things that happens in whatever we do, chemical engineering has a role to play in every one of these, right? So it is important to understand that you have to really have a bird's eye view of all of this and also go into some specifics based on your interest. And to understand all of those, you have to understand chemistry well, but most importantly, physics well, and you have to be really adept at mathematics. Because right now, with lots of things being understood by computer models and things going digital, you have to develop a theory for which you need a very good understanding of the math, physics, and then being able to write it in the language of mathematics, which is your partial differential equations and so on. And then sometimes these equations can be directly solved. In many cases, they cannot be directly solved. So you do the simulations to find solutions for these equations and then test it experimentally and then check whether this works. So essentially, when you think about chemical engineering, then what are the key skills that you will need? You will need good understanding of mathematics, good understanding of physics, good understanding of chemistry so that you can put together these models to understand chemical systems. And then you need computational experience and expertise to develop simulations based on these models, and then use the simulation results with the experiments to identify whether what you're predicting is correct or not, and so on. Just so that I kind of tell you what is possible, I just came towards the end of the last session. There were questions about because of AI, will jobs go run out for CSE and so on. Jobs are one thing I think you should not worry about at this point. The only thing I can tell you is whatever field you choose, if you learn that well, and then you're a creative person, jobs are not going to be a problem. So here, this is from one of the chemical engineering magazines, I think, you can kind of think about so many jobs that will get created. And particularly when I talk to you about the climate, the energy, and so on in the previous slide, maybe a space fuel processing problem needs to be solved. That's where chemical engineers could find jobs. Nano manufacturing. How do you grow agriculture vertically? That might be another job. How do you 3D print food? Already people are 3D printing tablets and medicine, personalized medicine. Huge job potential. How do you live sustainability? How do you make things green? Green process engineer, climate change reversal engineer, personalized medicine, understanding genetics and so on, genetic farmer. So you can think of any number of these, and many of these will actually involve chemical engineering principles. And if you are really solid engineering student, you should be reasonably straightforward to find jobs in any of these fields. So the real question is, for this whole field, we should be educating young folks like you to really take a lead role in all of this. So our job is to keep the courses enough interdisciplinary, with enough freedom for students to take several electives so that they are ready for all kinds of these challenging jobs. And they are able to work and then make a career out of any of these jobs. So at IIT Madras, and I'm sure this is true of all other IITs also. So I'm just talking about things that I know. One of the ideas that we have is that every engineering, there is a set of core courses that students need to take, which will make them that engineer. But we need to have enough electives now and allow these electives to be very free. Even if you have electives and then say all of these are electives from, this basket of electives only chemical engineers can do, this basket of electives only electrical engineers can do, and this basket of electives only computer science students can do, and so on, then it stops the purpose. So what we have done is we have a core set of courses, and we have made our curriculum broad in such a way about 40% of all the courses then become electives. And these are actually quite free electives. So they are not, so we have two types of electives. One is a professional elective, which is elective with related to chemical engineering, and then a free elective. So we have enough option in terms of free electives so that the students, while they are pursuing any engineering that they want, you can go on to the electives and learn a lot more. And I'm going to tell you this, and this is going to be the most important thing, because ultimately, while many of you might worry about career, job, and so on, that is not going to be the problem. My real feeling is as the world gets richer, and definitely India gets richer, I think all of us will have enough jobs, minimum living standards that will go up. What is important as we, and this was not as important when I started, because we were really thinking about what jobs will we get, will there be enough jobs, will India grow, and so on. So all of those questions are answered now. What is more important is how do you live a life where many of your basic needs are met, but you are doing something fun, you're doing something interesting, you're doing something meaningful that is worthwhile, right? And to be able to do that, you have to be really agile. So I honestly believe that when I started my chemical engineering, I could have imagined myself being chemical engineer till my retirement, right? And which is pretty much going to be true, though the last phase of my career, things are changing dramatically. But what was chemical engineering in my head and what I did itself was very different. Nonetheless, I am still identifying myself as a chemical engineer. I could start as a chemical engineer and end as a chemical engineer. However, the future is going to be different. So whatever you do now, 30 years down the line, it's very, very difficult to predict the rate at which things are changing. So I think in some sense, it de-emphasizes what exactly you do right now. What you need to do is learn, generate this curiosity for learning, and then be open-minded to be able to work in any interdisciplinary field you want, which is exciting to you, not be forced by anyone else or because everyone is choosing something I'll also choose. That's a very poor approach, because that's going to basically make you lose your enthusiasm for what is the most important thing. Because what is the most important thing, I believe 30 years down the line, is going to be, how do I find something that is exciting to me and meaningful to me? And I'm doing that not to eat, not to fly, not to live life, but actually a lot more, because the basic things are already there. How do I do something more? And then I want to get up every day and then say, hey, I love doing this, I want to do this. So that is going to be the challenge. So my recommendation would be, don't worry about the future in terms of, will I get a job in this branch and so on, but worry more about how do you find that thing that is very exciting to you, that thing that is very interesting to you that you want to pursue. Now, at your age, it's difficult to understand this. So you will almost always never go wrong as long as you keep the enthusiasm to learn as you go forward. Okay, so I will stop there, and then I'll be happy to take any questions that you have. Okay, I see one question. I've heard it many times from some of my seniors that the chemical engineering is not same. How significant is and is being a good? No, okay. So I already answered this question. I think chemical engineering and chemistry are very different. Chemistry is basically doing the basic science to identify reaction pathways to make materials and so on. And chemical engineering is actually taking this and scaling this to a plant level so that you can produce it safely, sustainably and so on. And I maybe should not admit this in this meeting, but if you ask me, am I great at chemistry? I don't think so. There are people who are much better at chemistry than me. But if you ask me, I'm a good chemical engineer, I would say, yes, I'm a very good chemical engineer. So chemistry is a prerequisite, but it's not, in fact, I hardly use much of chemistry other than an abstraction of chemistry in terms of reactions and so on. So that is what I would say. Does chemical engineering require very high level difficult maths? No, it doesn't require very high level difficult maths. It requires maths, right? If you have to be good at solving partial differential equations. You have to be good at numerical techniques and so on. And all of those are actually quite exciting in terms of things that you will learn. And once you learn those, chemical engineering is super fun because you can use these tools that you have learned, as I said before, in multiple fields. Okay. What are major differences between chemical and mechanical engineering? Okay, now it's a very interesting question. Many of these disciplines have cross borders. If you think of basically things that we conserve, the conservation principle, it's very easy at this level to explain from that. So as chemical engineers, we are very worried about chemical systems. So we are very worried about mass balances, right? So many moles come in, so many moles go out. How is that balance? So we want to understand that. So mass balance is important. Of course, heating, cooling for reaction and so on, energy balance is very important in chemical engineering. So I would say these are important aspects that are part of chemical engineering. While mechanical engineering, you're looking at mechanical systems and so on, where the more focus is on momentum conservation and energy conservation. So if you look at conservation, it's not that momentum conservation is not thought about or momentum balance is not thought about in chemical engineering. It's thought about, but the prime pieces are actually mass and energy. In mechanical, the prime pieces are, I would say, momentum and energy and so on. So those are physical systems. These are chemical systems. Okay, can I do masters in AI? Oh, of course. Sukman, this question, you can do anything you want after a bit in chemical engineering. And I'm telling you, I did a PhD in AI. So it just depends on what you like and what you want to pursue after you finish chemical engineering. And essentially, you can do anything you want. You can do quantum mechanics, quantum computing, everything. Nowadays, of course, things are becoming much better. We don't have the silos. You can do a bachelor's in field and do master's in anything else. Is it true that chemical engineering is only? No, not at all. In fact, chemical engineering is about, in fact, it's ultimately, with all the concerns about energy, greenhouse gas, and so on, we are going to move away from fossil fuels to renewable energy and so on. And renewable energy is just an unbelievable array of technologies that you need to think about. As I told you, fuel cells, if you think about fuel cells, there are a whole host of different things which have nothing to do with oil. That you have to think about. If you're talking about solar cells, there is a whole host of other things to think about, and so on. Does pursuing chemical affect health? Sir, it's a direct question. There is absolutely nothing to do with health. Whether you're a computer science, you're taking computer science or mechanical or chemical engineering, Most of the time, you're going to be doing hand calculations, sitting in a computer lab, and so on. So there's no connection between health and chemical engineering. In fact, hopefully many of you will take chemical engineering and solve some of the pollution-related problems, so the health of the whole world actually improves. It's a job of a chemical engineer. Again, same question. It is even if you're working in a company in India, most of the time, because of all of this automation and IoT and so on, you're still sitting in an office trying to figure out what is wrong. There are very few chemical engineering graduates who have an undergraduate bachelor's degree who are really walking around in field, getting exposed to hazardous chemicals and so on. That doesn't happen. No, not. Then the next, I heard that is not how significant is if a student is not. Student need not be great at chemistry. It's good to be good at everything. So, as a faculty, I will say it's good to be good at everything. But again, like I said, my interest was actually largely math when I started my undergraduate and physics. And it has continued to be so. And I would say I'm not really great at chemistry, but I've done quite well for myself in chemical engineering. But having said that, I just want to, because there is this notion of, there seems to, many times when I'm in these kinds of settings, there's this question about chemistry, memorizing, and so on. That's changing, right? Remember, chemistry, you have to think about chemistry very, very differently. I think with the kind of things that are happening, ChatGPT, with even before ChatGPT with search, you have a phone, internet all the time. You don't need to memorize anything nowadays. I think it's a very poor thinking to say, do I need to memorize a lot in chemistry? Chemistry is actually a fascinating field. Okay, and if you really think about understanding the molecular structures of these things and really get a fundamental understanding and thinking about chemistry not as something I'm going to memorize, then you will understand the richness of the field, the excitements that can happen. So basically, when I think typically when students prepare for these competitive exams, time bound, you have to commit things to memory and reproduce and so on. That stops at that point. Beyond that, chemistry is about really understanding the beauty of how these molecules are organized, how things happen, and so on. So it would be very interesting to know that even in chemistry, all this DFT calculations and so on have a lot of math. So computational chemistry is a huge field in itself. So the notion of memorizing multiple things in chemistry is only at that preparatory level. Beyond that, I don't think it is like that. Your opinion on biochemical engineering, excellent field also. In chemical engineering, you also add bioorganisms which have a richness of their own and then use similar principles to understand that. I think it's a fascinating field. Again, think of drugs, drug discovery and so on. All of those are going to be important things that going forward. So we know from COVID, the race to produce the vaccine and so on. Who are the people who are working there? You're having your biochemical engineers, your biologists, chemists, chemical engineers working there, making these things. So it just, again, what I want to emphasize is that whatever you pick, learn that well, enjoy it, and then there's just lot of opportunities. I heard that mechanics are not allowed for masters in. No, absolutely not true. That I don't know where you heard this, because, for example, at IIT Madras, whatever engineering that you start with, after 3 years, we allow students to upgrade to a dual degree, and they stay 1 more year, but they get a bachelor's and master's together. For example, I know many chemical engineers who have taken data science as the dual degree masters and gone on to do data science. So there are many chemical engineers, students who work with me, who are chemical engineer undergrads and data science masters from IIT Madras. So there are about 10 interdisciplinary courses that we have started like that. Just to give you an idea, robotics, quantum science and technology, energy systems, data science, and any engineer can get into any of this. So for example, you could be a metallurgy and material science student who finishes with a bachelor's in metallurgy and material science and a master's in quantum science and technology. You could be an aeronautical engineering student who finishes with a bachelor's in aeronautical engineering and a master's in nano materials. Okay, so we have made this very easy. And so these are not true at all. So don't believe in any of this. This is true. Not again, this is another interesting thing. I was very surprised, and I used to be told this also in when I was an undergrad. I don't think that's true at all. Nowadays in chemical engineering, again, I can speak for IIT Madras, you have to work quite hard to do well. In fact, did you know that, so when I went to the US to do my PhD, many people will meet me and they say, hey, you're a very smart man, boy, or whatever. I say, why you're doing chemical engineering? So they used to think in the US, chemical engineering is the hardest job because there are lots of PDEs and so on. So all of this doesn't matter. There's nothing hard or easy. And it also depends on how well you want to learn something. So if you want to really learn something really well, you're passionate about it, and then you have to do it well. That's it. And all fields will give you challenges, and all fields will. There are points in which semesters where you'll have to work very hard. There are semesters where you can relax a little bit, but everything you have to put in your time and work hard. Generally, it is observed that an exam more on factual. Exactly. I cannot agree with you more. How, according to you, can this problem be solved? Sir, very simple. Unfortunately, maybe 10 years down the line, the JEE itself will be very different. So we don't know how to predict these things. But right now, we get through this. But once this is done, then when you actually learn a subject, you learn. And nowadays, the resources are so much. You just have to go to YouTube and there are fabulous lectures. And of course, there are very good faculty teaching some of these courses. So once you get into the field, okay, your view will change. Then it only depends on how you are going to approach this. Are you going to still say, I will learn this in the last minute and cram many things into my head and go and write an exam? That's one approach. If you are like that, that will be what you do all your undergraduate curriculum. But if you take the approach that, okay, I'm going to spend time, I'm going to understand, I'm going to learn, and then go through this, then you will see the beauty of every one of these fields. One thing I've learned myself is there is no boring field, there is no memorization field. All of these are poor, wrong notions. All of this only reflects on how you look at what you're learning, but it does not reflect on what is being learned. Because each of these, remember, every small question that mankind has answered is profound, right? Imagine thousands of years back when someone had no idea about anything from there to think about the atomic structure, right? And all of these orbitals and so on, to come up with this whole idea and understanding of how things are organized. It cannot be memorization, right? It's just unbelievable intellect that puts all of this together. Now, once we know all of this, because we are lazy, we don't want to understand this completely, we'll just say, I'll mug this up, I'll do that, and so on. I think that reflects on us rather than on the field. So this is something that I strongly believe. Toughest profession, I don't think so. There's no one engineering which is tough, another one is not tough. And also remember, every student is naturally good at some things and not good at something. And every one of these engineering fields will test you on different skills. So you will go into some courses and you'll just ace it because you are naturally inclined towards that. And there are some courses where you will have to struggle, whatever be the discipline it is, because you are not naturally good at it. So then you'll put in more work where your weaknesses are, you will improve and strengthen. And wherever your strengths are, you'll coast through. So this is true of every discipline. So that is something that you want to remember. So it's not that one discipline has all difficult courses, another discipline has all easy courses. All of those are unfortunately at a high school level. When you're trying to get into these things, people tell you all of these things, none of which is true. And even if you talk to your people who are in IITs, the students who are doing undergrad, some of them will say the same thing. And then you might ask, hey, they've gone into IIT and they still feel the same way. It is not about what they feel. It is about how they are approaching to learn, to this notion of how do I learn. Okay, so that is important to keep in mind. Okay, I think chemical industry is going to grow tremendously, but it has to go with responsibility, right? Because you need to be sustainable. You have to worry about climate change. At the same time, if you want to solve these problems, you have to produce materials which have really fantastic properties, right? If you want, higher efficiency of solar cells, you want lightweight materials. Technical challenges are many next 20, 30 years to solve many of the materials problems, which will really help with sustainability and energy. It's important that chemical engineering provide solutions to many of this. And it's going to be a challenge. At the same time, it's going to be a great opportunity. Okay, I think there is an IIT Madras because the problem. This is a question that I'll find very difficult to answer. I'll tell you one thing. I went through IIT Madras myself. And I think I had a lovely time. There were times when I really worked hard. There were times when I really enjoyed myself. I can tell you very honestly, and this is not any promotion of IIT Madras. My time at IIT Madras has been one of my best 4 years of my life. I spent at IIT Madras enjoying myself. So one important thing that I would really like all the students to understand is that there's no need to put pressure on yourselves because life is very long. I can tell you, I've been in technical field for now 35 years. And if I pick out some 5 years somewhere in the middle of my life and then chuck it out, okay, I don't think it'll make any difference to where I am in my career. Unfortunately, when you're young, it looks like every month, every year, what you do then is going to make or break your life. What you then is not going to make or break your life at all. Once I think you understand this, then you start enjoying what you do, clearly knowing that in the future you will do well. Okay, so if you take that approach and people actually tell you this is the truth, you might have a student who is 9.5 who might say 1 crore job I have got. All that is pointless. All that is pointless because, and I think Jainam Shah is smiling because he's heard this multiple times before, I think. But I can honestly tell you all of that is pointless, and particularly so now, at least when we were undergraduates, because there was a big difference in terms of money, what money can buy and so on. But going forward, people who are going to get into IITs who have already got into a level of living, I think it's pointless. So pressure to some extent is depending on how you view your life. So you have to take control of your life and say, whatever it is, I'm going to do what I have to do and being sure that you'll be taken care of. And life is very long, and this 4 years is still a very small part of the journey. Okay, one more question I have. I'm kind of interested. Explosives and weapons. Yeah, excellent option. You can learn a lot. If you have that kind of specific interest, that's fantastic because you can focus on courses that make a difference and make your understanding better. And like I said before, the key idea is to make as many electives available as possible so that people can follow their passion. Okay, I think all the chat questions I have answered. There are, don't know what's next.
Thank you so much, sir, for your time. If all the questions are answered, it was a great session, and I'm sure that the students have great insights with the session, and they would love to join chemical engineering at different IITs and colleges. Yeah.
I hope so. Anyway, thank you so much, and I hope I just want to leave by saying only one thing to all the students. I call them kids here. Don't worry about future so much. I don't want to sound like some guru here, but worry about what you learn and worry about having fun when you're learning this. Don't compare yourself with anyone else. Every one of us is an individual. We have our strengths and we have our weaknesses. The people who admire, we think they have only strengths and no weaknesses. Absolutely untrue. I have not found a single individual in my 53 years of life who has only strengths. So just believe in yourself, enjoy, and you'll have a great career. Okay? Thank you very much. And I hope to see some of you in my classroom sometime in the future.
Thank you, sir, for your time. I would like to thank all the participants for their active engagement and all the professors to share the knowledge and the expertise with us. Also, I would like to photo of a group session. If everyone could turn on their videos.